Rashmi, shall we wait for 2 more minutes? Participants are registering,
Sure,
joining.
sure. Yes, sure, sir. Sure, no problem.
Yeah, we'll wait for 2 more minutes. Then
Okay,
we'll start.
yeah. Okay, sir. Am I audible?
Yeah, please.
Okay, sir. Predicting the future isn't magic, it's artificial intelligence. And these were the words of Dave Waters. Good evening, all. I'm Amina, welcoming you all to the pre conclave events on International Conclave on Generative AI and Future of Education. This is the third event conducted by College of Engineering, Karnagapalli, as part of International Conclave on Generative AI and Future of Education. International Conclave on Generative AI and the Future of Education is a platform where global visionaries, educators, and innovators come together to discuss the impact of generative AI technologies in education. Immersive platform offers insightful dialogues, groundbreaking presentations, and collaborative sessions to explore the future of learning. Embark Embark on a journey of discovery, ethical exploration, and inspiration as we navigate the path towards an AI. Once again, I'd like to welcome Dr. C.V. Anil Kumar, Principal, College of Engineering, Karnagapalli, Dr. Resmi Ramachandran Pillai, Speaker of the session, dignitaries, and the participants to the event. The event is organized through Soho platform. In this platform, all the participants will be muted. If you have any queries, just raise hand, then the organizer will unmute you or use the Q&A session. The session on Expert Talk on Responsible AI is going to be handled by Dr. Resmi Ramachandran Pillai. Dr. Resmi Ramachandran Pillai is the postdoctoral research associate at the Institute of Experiential AI, with a background in privacy-preserving synthetic data generation that considers dimensions such as fairness, explainability, utility, and privacy. Her research has been applied to bias and discrimination problems in healthcare, computer vision, and more. Her research involves around the development of responsible, cutting-edge deep learning techniques that tackle complex challenges in generative AI. One of her primary focuses lies in designing syntax-agnostic models using generative adversarial networks and diffusion models in generating fair synthetic data. Additionally, she specializes in detecting and correcting various biases and ensuring fairness and accuracy in machine learning models. Prior to joining EAI, she was a postdoctoral fellow in artificial intelligence and integrated computer systems at Linköping University in Sweden. During that time, she was an active member of Taylor, the largest network in Europe for trustworthy artificial intelligence, and has contributed to collaborative publications, including the Encyclopedia of Trustworthy AI under Fairness and Equity by Design. Furthermore, she has demonstrated her commitment to fostering knowledge and skill development by participating in various workshops, summer schools, poster sessions, and international collaborations. She has also guided masters as well as doctoral students. Rashmi did her PhD in spiking neural optimization at the National Institute of Technology in Tiruchirappalli. Following that, she held a role as an assistant professor at the Indian Institute of Information Technology in Kottayam, India. In the capacity, she instructed graduate, industrial masters, and doctoral students in the fields of machine learning and deep learning. Without any further ado, I request Rashmi ma'am to take over the session.
Am I audible? Hello?
Yes, ma'am.
Yes, Rashmi.
Thank you so much for the kind introduction. First of all, I would like to thank the authorities, especially the director of IHRD, Dr. V. Arun Kumar, for having this idea in mind and having a section on generative AI and its applications in education. So I really appreciate the effort behind it. Also, I would like to acknowledge the entire crew of CEK, led by Dr. CV Anil Kumar, the principal of College of Engineering, Karunapalli, for having me here and giving me the opportunity to be a part of it. So I'm really thankful to that. So I think without further delays, I'm good to go with the presentation. So let me share my screen first. Is it visible now?
Yes, ma'am, it's visible.
Okay. Yeah. So let's get started. So today's topic of interest is responsible AI. So I'll start with the agenda of today's presentation. So I'll be starting with where AI made history and then why we need responsible AI, that main motivations and different principles involved in responsible AI. And then we discuss some interactions and challenges, of course, the pros and cons of those, including those responsible AI principles in the AI development lifecycle. Then, since this conclave is about generative AI, I would like to discuss some concept of when or what happens when generative AI meets responsible AI, which is a very promising direction in recent years. And then we will discuss some myths and reality, followed by some key takeaways. Good to go, right? So let's get started with an initial slide where AI made history. I'm pretty sure that most of you are aware of this history. That is in 1997, IBM's Deep Blue beat the chess world champion Gary Kasparov. And then in later 2016, Google's DeepMind AlphaGo learned to play the game and beat Lee Sedol, which is who is a world champion, right? So I think till that 2016, AI has been widely used in interaction purposes or interactive games like computer games or sort of things like that. Then later in 2020, Google's DeepMind published a paper in Nature suggesting that they had developed a product and it can detect or spot cancers from the mammography images. And the main advantage of that approach is that it has fewer false positive as well as false negative compared to the experts in their field. I think from that point onwards, we started trusting AI because AI is entering in the newsroom, AI is entering in the healthcare industry, AI is entering in privacy sector and many other sensitive, high stakes sensitive domains, right? So why we need this AI? Because AI, we know AI can do wonders. So what is the responsibility behind this, or why we need responsible AI? So I would like to bring this quote by Brad Smith, who is the president and chief legal officer of Microsoft. The more powerful the tool, greater the benefit or damage it can cause. Right? It is very true, right? That means, always, there are two sides of a coin, right? So far, we have experienced or exposed the enormous capabilities of AI in different applications, like including Chat GPT or query answering and computer vision, pattern recognition, everywhere, right? But the other side of the coin, that means I wouldn't say there's a negative side, but the other side of the coin has not received the attention it deserves. That means the responsibility side is still yet to explore. So we are taking a deviation from the normal cliche performance measures like accuracy, recall, precision, or whatever metrics that we are using. We are just shifting from the performance measures to the responsibility side, right? But that doesn't mean that we are sacrificing the performance. Okay, so this is why we need responsible AI. So can we just recollect the good old times where we used computer as an assistant tool for example, a data entry operator or a user feeding records or files to the computer, and we use computer for simple mathematical operations like excels or word or sort of things like that, right? Then machine learning came to existence, then the data entry operator is replaced by a data scientist who is very well known in handling the data management or data pre-processing and data storing activities. Then that point onwards, like we started trusting because there is nothing to worry because there is a human who is involved in all these activities. He can manage and he has the full control over the entire machine learning life cycle. But after that, because of the development of our like resources, computational resources, that means CPU is replaced by GPU, and the availability of enormous amount of data, machine learning is gradually replaced by deep learning, right? So we don't know what is actually happening in the deep learning models. For example, feature extraction is included in the like the network itself. So we don't know what features they are using, or what is happening inside the deep learning models. So why we need responsible AI? Because we need something to control the all AI development life cycle. So what is responsible AI? So when we go, we have seen like responsible AI everywhere, or we need to control those in AI development life cycle. But what do you mean by responsible AI? So it is just a framework, encapsulates a set of guidelines or principles from an ethical, technical, or legal point of view. I have seen many papers where different authors use different nomenclatures for this, but I would like to stick with these fundamental principles, which is generally adopted in responsible AI, from fairness to transparency or interpretability, to privacy and security, accountability, reliability, and safety. So these are the five most important principles in responsible AI, so that we can control over the entire life cycle. So we will just delve into each of these sections in detail in the upcoming or subsequent slides. Yeah, let's get started with the fairness. So I would like to start with the problems of unfairness. So I think you can see the figure on the left, where you have a model, and it is suppose it is a shape detector, and you have a training set of class 0 and class 1. So class 0 contains like circles, or the yellow, sorry, orange and blue, and class 1 contains a green and yellow, right? So there is a feature learning process and the representation space, and it classifies blue and orange as 0, green and yellow as 1. But the problem is, when it comes, this is training set, right? It is perfectly fine because it is getting a near optimal accuracy, which is almost equal to 100 percentage. But when it comes to test set, there are some combinations of this shapes, like it is not like the training set. The distribution of test set is different from the distribution of training set, but the representation space got confused. What's the problem here actually? So here, when we just like deep dive into the representation space, it is the algorithm here, or the model here, is a shape detector. But instead of detecting or understanding the shape of the training set, what it has learned is just like a spurious correlation. That means whenever blue and orange comes, it should classify as class 0, and whenever green and yellow comes, it should classify as green, no, class 1. So this is the thing that they have learned, right? The model has learned. That means it has learned a spurious correlation other than the the main task in the main task here, right? So the problem here is, it is due to the biases or the spurious correlations between the training data set. So when you deploy this kind of models in real-time applications, your performance will degrade, right? So this is one of the examples of unfairness, which is due to the biases in the data or the training set, right? So I would like to also quote another example from NLP. So this is suppose this is a language translation task, where you have a prompt like, she is a programmer and he is a nurse, and you're asked to translate this sentence to Turkish, right? So see, for example, I don't know how to pronounce it, sorry, but still you can just see the she and he is replaced by a single pronoun, co, right? It is perfectly fine, right? Then when we convert back to English, right, when we just give this Turkish sentence as input and ask the model to convert that to English, see, there is a interchange, right? Because he and she got interchanged here, but because he is it becomes he is the programmer and she becomes the nurse here. So what is the problem here? It is because of the spurious correlations in the word embeddings, because he is always mapped into programmer and she is always mapped into nurse, right? So these are the kind of biases involved in the data and the model. So this is the problems of unfairness, which is due to the biases. And what is the after effect of biases? It is called discrimination. right? There are mainly two categories of discrimination in AI, which is one is the first one is direct discrimination, and the second one is indirect discrimination. In direct discrimination, if the model is using explicitly a sensitive attribute of yours, that means, for example, if you're asked to if you're asked the model to predict whether this person should be hired or not, then the model uses your sensitive attributes like gender or race or ethnicity, then you call it as a direct discrimination. But which is very easy to tackle, because we can just check the model whether the model uses any sort of sensitive attributes, then you can eliminate that. That is very easy to tackle. But there are some other categories of discrimination which we call as indirect discrimination, which is not intention. Because like for example, you must be this tall to work here. For example, like in Indian, like you must be this 180 centimeter or 175 centimeter tall to work here, which indirectly causes a certain group to be biased. That means, for example, I think it, at least for Indian cases, like women are like the average height of women is less compared to men, right? So this is causing a particular subgroup which is not used by which is not caused by the explicit use of a sensitive attribute, but it indirectly causes discrimination. So this kind of discrimination is very difficult to tackle, because we don't know, because this tall is not at all a sensitive feature as per the General Data Protection Act by EU and US. So it is very difficult to tackle this indirect discrimination. So but once we know that there is a discrimination or bias, so we need to quantify those biases, right? So for that, we can have fairness matrices. That means these matrices are something we can compute between the differences between two groups or two individuals. Then we can tackle these biases at the origin of data or model or something like that, right? So based on the type of fairness metrics, you can have group fairness. That means a similar group. That means, for example, in our case, men and women should receive similar like a false positive or equal accuracy kind of performance matrices. And individual means two individuals in a same group should receive equal outcome. And there are also causality based fairness metrics, where we just deep dive to the origin of the bias and then remove it. So I'm not going to the details of the mathematical notations and theoretical contributions of this, but still, these are some kind of fairness metrics that you can use to quantify the biases in the data and model. So, so we have quantified the biases, right? Then we need to mitigate those biases. So we know there are like three objects in our AI development, main three objects in our AI development life cycle. One is data, another one is model, and the last one is decisions. So if you are incorporating your bias mitigation in the data, then we call those algorithms a pre-processing algorithms, because you are applying some kind of balancing data set, or removal of sensitive attributes, something to the data, then you call it as pre-processing algorithm. Then in processing algorithm, you are applying some bias mitigation techniques in the training time, right? Then those types of algorithms are called in processing algorithm. And the post processing, of course, if you are doing some adjustments at the outcome of a decision, then it comes under post processing algorithm. So if you want to get more idea of how this works and what are the algorithms involved, you can just go Google. Like there is a review paper which lists all the bias mitigation approaches for this particular case. So it is very useful. It will be very useful for you. Yeah. So far we have talked about fairness. That means fairness is caused by biases, and then we can quantify it, then we can mitigate it. So the next important principle is explainability or interpretability, or there are other nomenclature like transparency. So what is the main motivation behind explainability or interpretability? That means uh, like this AI is entering into high stake domains, as we have already discussed, because of healthcare and privacy and security. So model understanding is very important in this case, right? For example, let me quote one well-known example. It facilitates debugging. The first motivation is facilitates debugging. So for example, if you have a model or a prediction model, then this model is a kind of classifier, and it takes input a Siberian husky over here. Okay, then it classifies as husky. It's perfectly fine, right? So there is no problem at all. But I want to understand the model, why the model has arrived at the the prediction husky. So what I do is I just explain the model or interpret the model. Then what I got is a kind of activation map like this. So then I came to know that it is not a, for example, it is my model should take the the attributions or the features from the face of a husky. Then based on those features, it should be able to classify husky or not, right? But what they have done is, what the model has done is, it just looked at the the surroundings or the snow. Then it based on the, if there is snow is present, then the model just classified it as husky. Because this Siberian huskies are very popular in cold countries in Europe or America, or somewhere like that. So it is just a snow detector, and it is not a husky detector. So this is the motivation. So it facilitates debugging, because when we deploy this model in real world applications, there may be some other Siberian huskies where the the snow will not be present, right? So then it will misclassify those input images. So the first motivation is it facilitates debugging. So the second one I would like to call is like recourse to individuals. For example, or for instance, suppose Sam applies for a mortgage. Okay, then we have an AI model which predicts whether the loan can be granted to Sam or not, right? Then the Sam input all his details to the AI model. Then it predicts the estimate or Sam's probability of defaulting. That means whether it can be granted or not. So for instance, we can assume Sam's mortgage application is rejected for this purpose. Then what we can do is, see, I can explain. So instead of getting a positive or negative outcome or a Boolean outcome, Sam wants to know why the model has rejected my application. So what you can do is you can explain this AI model and just give some idea to Sam that, okay, this is the guidelines. So you have to improve on these things. For example, you want to repay your all loans, or you have to increase your salary by this much percentage, then you will get loan in the next time when you apply, right? So this is we can just give a more elaborate recalls or the guidelines to individuals. Okay, so this is one of the motivation I would like to include. Then another thing is, if some gets a in the guidelines some received, some is seeing, okay, you want to change your race or ethnicity to apply for this loan. So this we can say, okay, then some can understand, okay, AI model is using my sensitive features, then you can detect biases in it. So these are the main motivation behind all this transparency, interpretability, or explainability. So why we need model understanding, that we have already seen. So what are the types of or categories of model understanding at the moment? So we have different mainly two branches of it. One is inherently interpretable models, and the second one is post hoc explanation methods. So what is inherently interpretable models? That means by looking at the structure of the model, for example, it will be a simple model like linear regression and a decision tree classifier. So by looking, so if you want to analyze why the model has arrived at this decision, you can just go back and this this path and just get the rules, right? Because it is inherently visible in the model itself. But this is very simple model. So those who are using machine learning models, like maybe simple models, then you can just go for inherently interpretable models. But there are some other categories that is called post hoc explanation, which is very which has got many attention from research community in recent years, because of we are in almost all applications we are using deep learning, right? So this is, for example, if this is a deep learning model and it is very difficult for looking at this model, and you are not getting anything from the model, right? You are not understanding anything from the model. So what you can do is you can like create an explainer on your model, on your original prediction model. Then you can give that explanation to the user or the data scientist or whoever it may be, right? So the one we use to explain, that means the explainer objects or explainer models, that we call it surrogate models, and the main model is called as black box, because it is, we cannot see anything what is happening inside the model, right? So explainer, what is this a surrogate model? It can be a simple model which try to approximate the quality of the main model. So this will be the post hoc explanation methods. So I'll be discussing some more about this post hoc explanation methods in the subsequent slides, right? Okay, all right. Then let me discuss what are the methods which is available in post-hoc explanation methods. So there are mainly two categories of methods which is available in post-hoc. One is local based and the second one is global based. What do you mean by local based? As the name suggests, it is like explaining a single instance of a prediction. For example, if you have 10,000 instances, it will take one instance from your randomly from your data set and try to explain that model. Okay, there are many techniques involved in it, that maybe it can be feature based like lime, local interpretable model explanation, then sharp. This all comes under this local explanation methods. And also saliency map, which is very useful in computer vision tasks, and also counterfactual. These are some of the main methods we can just list under local explanation methods. Then there are global explanation methods. That is, global means the collection of local explanations, and it can be also representation based. So don't worry, I'm going to explain one example from each of these models. So this is one example. So I would like to explain this LIME, that is local interpretable model explanation. So as the name suggests, it explains a single instance of the prediction, right? So just select a point here that is denoted as a red X. So that is X. Okay. So what you do is, so first of all, I would like to say that this is the like non-linear decision boundary. See, this is the non-linear decision boundary of a black box model. So I want to explain the predictions of this non-linear boundary. So what I do is I will rely on surrogate models, right? So for that, you have to select a point on the entire decision boundary of this. So I selected like this X, which is the X1. Let's say it is X1. So what you do is you just perturb this X to to get some more points on the decision boundary, right? Maybe you can add some Gaussian noise or sort of things like that. So you may get so many points around the entire the instance X, right? Then what you do is, like, the points which are farther away from X will get a lower weightage, and the points which are like near to the X will get a higher weightage. So you select only those points which are very close to the point X, right? Then what you do is, like, you just try to fit a normal or simple, for example, a linear regression model to classify those points around X1, right? So since it is a single linear regression, the coefficient of it will give you the explanation for that particular prediction, right? So this is the way the feature attribution based method works, like lime, kind of sharp, something like that, right? So this is the local explanation, because we are only explaining from the entire decision boundary, we are only explaining a point from the boundary, that means X, right? X1, right? So this is a kind of local explanation methods, which is like widely used methods as lime, right? Okay, this is one. Then second one is saliency map. That means if you have a bird in your input, then you want to know what features of this bird is used by the model. So what you do is, like, you compute gradients with respect to every feature of the bird. Then the one which having the highest gradient will have the highest probability selected by the model, right? So you will get a saliency map like this. Then you will get to know these are the main images or main contents of this bird, then which is used by the model for prediction. So that is the saliency map, which is also kind of representation based methods. Then there are some counterfactual explanations. So I would like to know why what is the deviation from the crested auklet to red-faced cormorant? So what is actually the model is trying to predict from crested auklet to red-faced cormorant. So when I do the counterfactual explanation for this, so I'm getting this portion. So this portion, because it is having almost similar structure, so when the model finds this particular portion, it deviates from, it differentiates from crested auklet to red-faced cormorant. So as you can see from all these local explanation methods, there are many challenges, right? Because we are only explaining a single prediction. So the expressive power of local explanation is very less, right? Because we don't know what some other instances in the, the decision boundary, and how they are classifying, or how the model is using those instances, right? And also it has lack of generalization, because we cannot generalize based on this single point, right? And also it is uncertain and unstable, because you may get similar explanations for two different predictions or two different images. So these are the main challenges in local explanation methods. So then when it comes to global explanation, I already told you, like, it's a accumulation, right? Accumulation of local explanation. So for example, we can just simply examine the same figure that we have seen in local explanation, because it is called SP line, that is single prediction line, which is a global explanation. So what you do is you select a set of points from the decision boundary, right? Earlier we selected only one point, but in global explanation for Lime, we select like a set of points from the decision boundary. So the one important criteria to remember here is the selection of points here should be a full representative or a complete representation of the entire decision boundary, entire nonlinear decision boundary. For example, if you already selected this single explanation, this black one, okay, but there is no point in selecting the red one, because the decision boundary for the red and the black is almost close to each other, right? There is not much deviation from this one. But you should select the blue point over here. That means it is perpendicular to the decision boundary. So you have to select only those points which is very unique from one another, and also it should represent the entire nonlinear boundary of your prediction model. So this is the single. Then you accumulate all these predictions, then you aggregate all these local explanations and come into the global explanation. So this is one kind of global explanation method. There are many more. I just want to make you like give you like overview of how this global explanation works. So I just picked one or two examples, right? Then okay, there is another kind of global explanation which is representation based. That means there is you want to know some features are important for your prediction. For example, you have a set of images like zebra, watermelon, birds, or like animal set of images, right? But you want to know how important is the concept stripes, right? Because you have different stripes in almost all of the images, right? So you just want to know the how important is the concept stripes. So what you do is you just classify, or you just take a surrogate model and you classify based on the stripes, right? So this is the kind of stripes you have in one, and another kind of stripes in another, right? This may be kind of other like zebra stripes. So these are like watermelon, or birds, or lions, something like that, right? So then what you do is you just compute a gradient with respect to this, the one vector which is perpendicular to the decision boundary. Then this will give you the importance of the concept stripe. Then you can say, okay, this concept is very important for this prediction. When this approach is called TCAP, that is testing concept activation vectors. So when this is useful is like, so for example, if you have a set of images, then you just want to see like what is the importance of a race on the prediction. So you can just now try and error. If there is an importance for race, you can just eliminate it using some other techniques, right? So this is but the stripes is not at all a feature, an explicitly defined feature for the animal, but you can just like you can just query by yourself using these kind of global explanation methods. So this is the main overview of local explanation and global explanations. Then let's come to the limitations of XAI. That means there are some limitations in explaining the main predictions of a model. So for example, in the first example over here, so there are two objects here, one is dog and one is cat, right? So but when it comes to the explanations, it only giving some special focus on the dog, not the cat. So maybe there are some other correlations here, but it cannot explain the complete predictions of the model, right? This is one of the main limitation of XAI. So another one is, so you have a ear grebe and horn grebe here. There are two different birds, but you are getting same explanation for these two classifications, right? So this, which is very unreliable. So lack of it, unreliable, I would say unfaithful. So these are the main limitations of XAI. And also it is very easy to modify the explanations using adversarial attacks. So if there is an adversary who has the intention of modifying your like explanations, they can just select some other points from the global explanation and just like give you some false explanation styles. there is one another important point to remember is this, the concept of deceptive explanations. For example, what happens if your surrogate model is also a machine learning or another model, right? I mean, it can be a simple model. So what happens, your surrogate model fails to approximate the behavior of the original model, because we have already seen surrogate model is kind of, it depends on like how the model is using those no, selecting those features, right? So this, if it fails to explain the complete behavior of the black box model, it comes into deceptive explanation. That means it also like even if your main model or the prediction model is good, if your surrogate explanations is bad, it will give you some bad idea, right? Then you try to then you use that as a feedback for giving the main model, then it can lead to some adversarial effect on your predictions, right? So these are the main limitations of xai. I hope this will give you a shed lights on some important concept of xai. So now let us like I would like to talk about some accuracy interpretability trade-off. So for example, this is for example, you have a kind of models like this, a sort of models like this, and it has like a increasing complexity from like top to bottom. So but the accuracy of this model is always increasing when you add complexity to your model, right? So one important point to remember is the more simpler your model, the interpretability will be very easy. But when you add complexity to your models, the accuracy will be high, but the interpretability will be very less, or it's very difficult. So one takeaway for this is, if you can build your own accurate in the inherently interpretable model for your task, just go ahead, right? There is nothing stopping you from doing that. So there is no need that always we need to rely on the high complexity model. So you just want to make sure your model or your inherently interpretable model is well defined based on your task of interest. That is the accuracy interpretability trade-off. So that's it about interpretability. Then let's talk about privacy and security. So there are some concerns like in recent years, how does your AI system use personal data? For example, in COVID-19 claims, the COVID-19 features or the data has been distributed all over the world. And what happens if insurance companies getting those like files, and they redefine your policies of claims or something like that. So that is not that should not be happen, right? So risk of re-identification is very important in responsible AI. So for example, there are some remedies proposed for this one. So like one is obfuscation. For example, if you have a set of images and you want to share your images with any AI model, or you want to try to you use censored data, or other kinds of your personal data, you can just blur the sensitive parts of your images, right? But there is a recent study pointing that if you blur your sensitive parts of your image also, it doesn't sacrifice accuracy. That means there is no accuracy deviation. So you can just simply go and blur the sensitive areas to your images. That is one important like latest study conducted on this obfuscation techniques. Another one I would like to say is PAID, that is private aggregation of teacher ensembles. So what happens is, you have a private data over here that is having some different layers here. Then you just divide the partitions, the whole data, you divide many partitions like this. Then you make a single model for each of the partitions, and we call those models as teachers, right? So one, for example, if you have teacher for marks and computer science and artificial intelligence, those are very good at their own field, right? So each teacher is capable of extracting or predicting their own partitions of data. Then what we do is, like, we aggregate all these teachers to get a complete idea of the private data. And you should make sure that this is happening in the private side. That means in the in an authentication or an authenticated organization. For example, there is no cloud or there is no distributed computing like that. So this is completely private. Okay, if an organization wants to share their private data to a second party or third party, it should be done in the organization. So now you have an aggregate teacher here who has the knowledge of all the partitions of the private data, right? Then what we do is, there is a third party or a second party over here who wants to, who is capable of predicting the public data, right? So what this student do is the student comes and just get the knowledge from the aggregate teacher. That means this aggregate teacher only shares the knowledge she or he got the from the entire training of the partitions, right? But they are not giving any personal data to the student, because student only wants to know the knowledge, how I should work, or what weight or biases I should work to complete this, task. It has a query access to the aggregate teacher. So this kind of private aggregation of teacher ensembles has been used widely in many applications, where in industry and organizations, kind of similar sort of applications, right? Then another important privacy method is federated learning. So this is almost similar to the first half of this, because you have different sensors and you have different partitions of the data. So what you do is you collaboratively train the model. This is the global model, these are the local models, right? So this lap or your mobile or whatever devices that you are on, then it collaboratively train a global model. Then the global model aggregates all the performance of the local models, and these local models are not shared with the public, but the global model can be shared with the public. So this is the main idea of federated learning. Another thing where I want to caught about the differential privacy, which is done by Apple. Because if you opt for your sharing system preferences for data analytics, for example, if Apple wants to analyze which emoji is very popular among users, so the moment when you type an emoji on your WhatsApp or chat or wherever it is, what happens is they adopt a differential privacy on your mobile, and then they just give a temporal timestamp. So then this emoji is going to the server, they just cut the device ID or the personal identification from the emoji, and then they use whatever information they need, because they only want to know the frequency of emojis the users are using. So they just only extract those information from your input. So this is kind of different approaches or privacy approaches you can employ for your machine learning or deep learning models to ensure the responsibility or privacy of your data or models, right? So these are some of the examples I have quoted. So that's it about privacy. And the next important principle is accountability, so which is very important. So what is accountability means? It can seek or leverage feedback for continuous improvement. For example, I think like you are all using GitHub, right? So what we do is in the GitHub we always give some specific instructions, so that when a third user or a second user come to your account and using your own code, he or she can understand what you are doing, right? So there are in a company side or in an industry side, there are three companies competing for getting the accountability. One is Microsoft and the Google and IBM. So from the Microsoft point of view, they developed a data sheets. That means it contains all the information of your data. For example, why the data was created, and who founded the creation of the data set. So, and what pre-processing or cleaning techniques you done in your data set, and did you have a privacy concern, or if you are using a personal or private attribute of a person, and when the data set is up. So all the information related to the data should be updated in the data sheet, and then we will keep this data sheet for future purposes. Like if there is any problem with the model or data, or if we want to update the data set, we can just look at this data sheets and we'll get information as easy as possible, right? So this is one of the accountability tool developed by Microsoft in 2021. And then the Google developed a model card. That means it contains all the information related to model. That means if you are using a face detector or a segmentation for computer images, the frame size that you are using, and what parameters the model is trained, and what are the different parameters you used in order to check or evaluation of your model. And then all the things, that all the things related to model, that means the internal architectures and the seed, everything related to the model is should be described in a sheet, right? So these cards are called model cards, which is very important for model documentation, because if somebody if there is a problem when you deploy your model, and if somebody wants to check whether the model is performing as the way it should be, then you can come back to the model cards and just check, okay, for this particular data set or this particular environment, it should be changed, the parameters should be changed. So that kind of information is provided by the model cards, which is a very good improvement developed by Google for accountability. And the third one is fact sheets for AI services, which is developed by IBM. For example, in an organization, your same model would be used for many different use cases. So the in a project management side, those fact sheets are like recorded. For example, this model can be used for this many use cases, and then in the deployment space, these are the like deployment. This model has been deployed in this application, and model 2 is deployed for application 2, and which kind of model enhancement you should do in the for deploying to the different applications, like that. So this is very important, because when you deploy the same model for different purposes like fine tuning or regularization or distillation kind of applications, then you can just go back to the fact sheets and see what modifications you have to perform for the different deployment stage. So these are the main three tools for accountability, which is very competing in this in this era or in this recent years. So it has got I think many responsible AI companies like Fiddler or Microsoft or Google are using these kind of accountability measures, which is very which has got very worldwide acceptance also in recent years. So that's all about accountability. And then reliability and safety, which is very important also. So what do you mean by reliability or safety in an AI system? For example, if you are deploying your model after you have done all the responsibility side, right? From transparency, fairness, privacy, accountability, then you are going to deploy it. So what happens if your model is not performing the way it should be? It is not supposed. It is supposed to do in some other way, but it is performing in some other way. So what happens? So how you handle those situations, right? So there is a worldwide acceptance measure called consistency, that which is a metric on how consistent an AI model in standard or outlier cases, because we cannot expect what is happening in the real world. There is many outliers present, or there are many the data is dynamic, and we cannot assure that the system will perform the way it has designed, right? So for example, there are many arguments are going on whether we should keep or remove the outliers in the data set, right? So let's have a quick introduction of what is outliers mean in different situations. For example, suppose you have a model, and you have data of maybe 100 students in a class, and you are just averaging the height of those students, right? So for example, if you are getting a 200 centimeter height, then it is an outlier, right? It should be removed in this particular case. So then this is the outlier, and it should be removed in this particular case. But what happens the same scenario where you are averaging the salary of a group, maybe 100 purple group, and what happens suddenly if Elon Musk or Bill Gates come into the picture, because their salary average salary is very high compared to the other thing, right? So in that case, whether the outlier should be removed? No, because we need to keep those, because that is also existing and it is real time, right? So we need to keep those outliers in this particular case. So when this is applicable is in healthcare, because for example, if you are getting a heart rate like a heart rate for a patient, then there are some abnormalities in the spikes, like this, right? So then the doctor should know it is abnormal, and you should give precautions for this particular abnormal outliers, right? So if you remove this particular outlier, then there is no point in disease detection or disease prevention, right? So this kind of applications, or for example, in sensitive domains like this, the outlier is very important, right? So whether you should keep or not should be decided by a well-known person, which is who is full aware of the context of the application. If it is just like averaging the height of a particular group of students, then you can just simply omit it. But in healthcare applications like this, you should keep those outliers for it. And also another question to ask at this stage is the model output is repeatable or reproducible? Because we have seen so many GitHub accounts and having so many codes nowadays. You have access to those codes, but many of around 50% of those accounts or those codes are not reproducible. They are giving some instructions. Even if we are following those kind of instructions, the accuracy or the privacy or the performance is different from those listed in the paper or the articles, which is very important. So you have to give in many papers, like you might have seen that the conference interval they give, right? So those kind of repeatable and reproducible analysis should be performed in order to make your system reliable and safety. So these are some important questions to ask at this particular stage, right? Right. So like so far we have discussed the discriminative nature of for example classification or clustering or detection, something a sort of applications, right? So we have discussed how responsible AI should be performed in discriminative applications or discriminative AI models. Then what happens if generative AI meets responsible AI? I'm pretty sure you're all aware of generative AI in this area, like in this era, because there are many more models are coming in day to day daily life. So what is generative AI? So like so far we have discussed discriminative. So generative means you have a kind of data set and some model, or you are like trying to generate new data from the real data. That means the new data will try to learn to approximate the distribution of the real data. And there are many techniques available for generating, many models available for generative AI, like in tabular data, like generative adversarial networks, and for computer vision tasks like diffusion models, and then language models based on BERT. So I'm not going into the details of the theoretical contributions on this and model architectures and those. So what is generative AI? It's a branch of AI which focuses on generating new content, right? So there are mainly two categories of generative AI. One is large language models or hybrid language models, and another one is image models. So what are the applications of generative AI? So there are many modalities like this. So for example, in large language models, it can be text to text conversion, for example, in paragraph summarization or paragraph generation, some sort of applications like that, or a text to image. You are giving a prompt and then it generate an image based on the prompt that you have received, and text to video, text to audio, and text to decision. So these are some of the modalities in generative language models. And another category is generative image models. That means you are giving an image, then you just analyze what is the image based on the image that you have given as input, right, to the system, and image to image, and then image to video. So these are the applications of generative AI which is having worldwide acceptance at this era, right? So just let me come back to the responsibility challenges of generative AI. So we have already discussed the transparency, explainability challenges. So how this will differ in case of generative AI? Okay, so there are, so for example, it is a kind of question answer. So like, is the following sentence is plausible when you only shoot from the outside of the 18? So for example, just assume this is a prompt, and then we are asked the chat GPT or GPT-3 to just pick the answer from A or B, right? Then it put like B, which is plausible, because then they gave the explanation like shooting from outside the 18-yard box is a part of the soccer, right? So one important thing to note here is this explanation is very appealing to the human eyes, right? We trust here because it is having a very good explanation of the reason behind the decision, right? But in reality, like if we give the same explanation to another GPT versions, you are getting another explanation. Shooting from outside the 18 is not a common phrase in soccer, so the answer is implausible, right? So there is a difference because you are getting different explanations for the same query, right? So the complex internal architectures because this large language models like Chat GPT and all the GPT versions of text generation is trained by internet data. So based on the complex internal architectures of billions and trillions of parameters of these models, and it is trained using the internet data, it is like confusing with the word shoot. It can be shooting the ball or shooting like the real shooting incident. So it is getting confused. So the emergent behavior and the explanations are highly unreliable in this case, right? Because it is very important to note here, because generative AI has enormous applications in very in text summarization and question answering query kind of applications. So it is very important to note that you are getting different explanations for the same query, and which is not relevant for the particular application you are considering, right? So there are transparency issues in in generative AI and its applications in healthcare and in Q&A sessions and all. So let's discuss some unfairness problems in generative AI. So for example, you are giving a prompt like to I just because let me give an example. Like maybe for example, two Africans walked into a Texas church. Okay, then you are asking the GPT-3 to complete the sentence. So just look at the completion that GPTs or the recommendations the GPT-3 is providing. Like access and bomb, throwing chairs, open fire, shooting at will, killing. So all of these things are kind of violation, right? But that is not true, because maybe we going for some other to have it a coffee or something like that. But the GPT-3 is like forced to give a kind of violence answers here. So this is because of the data biasing, right? So when we, because this GPT is having many applications in healthcare or other as I already stated, it is very important to point here. So data, the one important problem here is, since these kind of models are trained using internet data and it is changing daily, going back to the data and correcting the bias is very difficult, because you have kind of enormous amount of data, and finding those particular points where the data having bias is very difficult. And also in some situations, in most of the situations, you can expect unexpected biases, so which is very challenging for the the corresponding task that we are considering. There are some solutions exist like fine tuning, because you can just add, you have a chat GPT foundation model, and then you fine tune for your like adding a fairness constraint or regularization parameters, something sort of similar solutions like that. But as I said, data balancing is often difficult because of the enormous amount of data this GPT-3 or chat GPT is using. So this is one of the concern of responsibility for unfairness in generative AI. Okay, so right. Then what about the privacy concerns? So for example, I think you might already know this, because some in some applications or some context, generative AI try to approximate the distribution of the real data. But in some kinds of, there will be some like generative models, it will just memorize the content from the real data. So when you give a prompt like this, it will try to give you the whole personal information related to that person or address, because it is memorizing some data. It is not learning to approximate the real data. It is just copying the data from your real data and just pretending that it is producing or it is generating some content, right? So memorizing training data in generative model has huge privacy concerns. Okay, and also for in case of images, you can see the training data set image and the generated image here. So if you give a prompt like this, it will just get you the real image. So see, the difference is simply kind of like phase alterations, right? So this is very important because we are all giving data to GANs and like the face up. It is collecting your data and then generating your other another genre of images, right? So this is very important, right? It should not remember the data that we are giving, and it should give you, or it should generate a new image which is not identifiable by an adversary, or giving a prompt like this. So there are some solutions exist for these privacy violations, like differential privacy, as I already stated, and deduplication of data, which is very challenging as we have enormous amount of data. So this is the privacy concerns related to generative AI. All right. Apart from this, I would like to address some social impacts of like generative AI, which is very challenging in this applications on in recent years. I think you already know this. A man scammed by deepfake, because they are trying to pretend it is your close ones or relatives and asking for money, and scammed by some deepfake videos, which has got very attention in recent years. So this is one of the social impacts, and it's still an open challenge how to address those kind of adversarial effect on this. And also environmental impact, which is very important, because now everyone is using generative AI to build their own models for their own purposes from scratch, right? So the amount for example, if you see from 2018 to 2022, the amount of parameters, or the type of parameters, from 94 million to 176 billion. So the billions of parameters the models are using, right? So when you do your generative model, or when you start your generative model from scratch, you are or you are making more carbon footprints, right? Which is very bad for the environment, right? So in a recent study conducted by us, it is showing that, like, it has stated that the amount of carbon dioxide emissions for this generative model is almost equal to the vehicular carbon dioxide emissions, which is very shocking news for us, right? Because for training these billions and trillions of parameter models, it has to be in GPU, and the GPU is using enormous computational resources and emits carbon dioxide, right? So so our idea should be, or our motto should be, towards green generative AI. That means you have to preserve the environment also. So there are some solutions for that, because instead of training your generative model from scratch, you can just fine tune already existing model for your purposes, or customize the model for your purposes, right? And another important social impact is layoff. I'm not completely agreeing with this, maybe a 50%, but still there are some companies reporting that there are this generative AI forces some company layoff in recent years. So which is, they stated that the salespersons or the sales job are going to affect the most using the generative AI. So these are some social impacts related to the responsibility side of generative AI, right? So there are some other things also, but these are main important points we should consider from the responsibility side of all generative models, like large language models or diffusion models sort of applications. Great. Okay. Now let's discuss some myths with reality. The first myth I would like to introduce is, like, I think you know already, but generative AI can replace human creativity and innovation. So it is completely a myth. That means, for example, if nowadays generative AI is used for fashion designing, because like, it is very hard for those designers to draw the fashion based on customizable applications. But now they use generative AI for building their own models, right? I have seen many applications and papers related to that. But the important point to remember is, generative AI cannot think in a novel way. Whatever instructions that you are giving, the generative AI can be used as a tool for visualizing those creative ideas. But generative and AI cannot be replaced by like human creative, like generative AI cannot replace the human creativity and innovation. It can just assist you in making the decisions even better. That is the only thing. That is a very myth. And then the second one is, generative AI is infallible, which is very it's a real it's not a reality, it's a myth. That means we have already seen many cases where generative AI having incorrect predictions, incorrect generations, and incorrect explanations. So generative AI is infallible, which is a myth, right? So it is the reality is the converse, right? And then the generative AI is unbiased and objective, as we have seen from the example. It is also a myth. Generative AI is biased, and tracing those biases or origins of biases is very hard, right? And another important point to remember is adding responsibility decreases the performance. This is a real myth, because I have seen many papers that when you add fairness, when you add privacy, you are decreasing your performance. It is it is not a real thing, because adding responsibility doesn't mean that you have to sacrifice your performance. You can actually balance those methods. For example, you can take another model, even if you're adding some responsibility, kind of fairness or privacy. If your model's performance is decreasing, then just change your model or try with another model, so that you can balance the responsibility and performance. So it is a myth. So adding responsibility doesn't decrease your performance. Okay. So these are some of the myths I would like to bring your attention. Yeah. Finally, what are the key takeaways for this? So we have seen many responsibility challenges in discriminative as well as generative AI applications. So what is the main key takeaways for this speech? One is training data quality is very important for both discriminative as well as generative applications. If your training data is good, or a good representative of the real world data, and if you have a data scientist who is well known for how to manage or pre-process or clean your data, then your performance also improves, right? So training data quality is of the foremost important thing. And also from the responsibility side, proper evaluation should be needed prior deployment. So if you are going to deploy your model for different applications, you have to evaluate each and every principles that we have discussed, right? So for the better deployment in a responsibility point of view. And also, still there are some legal notions that yet to be framed. For example, in deep fake videos, and we don't know what is legal and what is not legal, right? So for example, if a company wants to produce a product, then it should frame some legal notions in which way it should be used, and the people are still unaware of how to use those kind of applications. So legal notions should be framed for ensuring responsibility from a like generative or discriminative perspective. Then another important point is beyond accuracy. So we all seen some papers, or many of the papers ends with accuracy related performance measures, right? But I would say you can always improve your accuracy. For example, if you use an ensemble model of maybe you use or you select some 10 models of high accuracy, then you ensemble it, you will get a better accuracy. But that should be the beginning of your evaluation result, I would say. The other things you have to add is transparency, and how this transparency of the model, and how should be the fairness of the model, and how the privacy violations occur, accountability and reliability, that should be accompanied by the accuracy or performance measures. So beyond accuracy is always a point. So accuracy itself cannot ensure responsible AI in all the applications. And then communication and collaboration, because now still we have we have many researchers, or ethical perspectives, ethical leaders or legal leaders, and but the communication between them is not that like effective, because they are not communicating and collaborating each other. So for a better responsible AI development life cycle, all these peers should be communicated and collaborated, so that you can develop legal notions. For that, you can just explore the dimensions from all the perspectives, right? So these are the key takeaways of the presentation. And yeah, I think I'm done with the presentation, and I'm sorry if I made you bored, but still, so I'm happy to take some questions at the moment.
If you have any queries, can raise hand or use the Q&A.